All right, 16. It says, consider the substitution reaction that takes place when R 3-bromo 3-methylhexane is treated with methanol. Which of the following would be true? So they give us a bunch of options here. They say 1, the alkyl halide does not possess a stereogenic center. So basically what they're saying is that this isn't an R molecule. It doesn't make sense. That just doesn't work, right? So I would think that's what they're saying. So option 2, they're saying the reaction would take place only with inversion of configuration at the stereogenic center, right? Which basically means that there would be an Sn2 reaction. That's when we get inversion. Option 3, the reaction would take place only with retention of configuration at the stereogenic center. Basically, that means that I guess the reaction would be stereo-specific, I think is the word. I'm not 100% sure, meaning that you wouldn't get you wouldn't get the R and S form. You would only remain with the R form, right? So, sorry if this microphone is low. And then 4, the reaction would take place with racemization. And then 5, no reaction would take place. So let's draw out the reaction mechanism here. So here's our molecule. Right? It's 3-methyl. It's R3-bromo 3-methylhexane. So we can see here's the bromine, and there's more carbons on this side than this side. So it goes in clockwise according to the Prelog-Ingold system, or the Ingold Prelog system. So it's R. And we're treating it with methanol. So we have a third degree substrate. So that equals no Sn2 reaction. We're not getting Sn2 reaction. So that means we can eliminate 2. 2 is not going to happen, right? The reaction would take place only with inversion of configuration at stereogenic center. Inversion happens when you have an Sn2 reaction. So we know that's not going to happen. We have a weak nucleophile. That's also a weak base. So that's going to give us Sn1, right, over elimination. So if we take our molecule, it's Sn1, right? So the bromine is just going to leave on its own out into the methanol. And that's going to leave us with a carbocation with the methyl group on it. This carbocation is going to be trigonal planar. It's going to be 3D, 120 degrees. It's going to be flattened out. So here's the methanol, right? The methanol can attack that carbon from the top, which is A, or from the bottom, which is B. And since, okay, so A and B, there's nothing blocking it coming from A or B. There's no, and neither A or B is going to be preferred here. So A plus B are going to be in equal amounts. So if it attacks from A, we're going to get the following molecule. Right? If it attacks from A from the top, it's going to push that methyl group back. Here's going to be the attached methanol. It's going to be positive on that hydrogen. And starting from here, you know, the Ingold Prelog system, I think that's what it's called, we would go clockwise, and that would give us R. And then B, if we went the B route, we went from the back, the CH3 would be pushed forward and the methanol would attach from the back, right? Here's the methanol with that positive oxygen. And since it's going backwards, if it's, you know, since it's projecting backwards, normally if it was projecting forward, you would go this way to go to the greater number of carbons. But since it's going backwards, we're going to go in reverse, and that's going to give us S. So we have two different forms, equal amounts, right? Just a side note, these H's here that are on the methanols, these two H's, they're going to be deprotonated, right, by the methanol that's in the solution. So they're going to be deprotonated, giving their electrons to the oxygen and making neutral species, right? So we have two equal amounts. Okay, we have A and B are in equal amounts right here. This is important. If you have equal amounts of the R and S molecule of enantiomers, you're going to get racemization. So the answer is 4. The reaction would take place with racemization.